and today we will study reduction of order. So now we are dealing with the higher order differential equations, and higher order differential equation, linear differential equation, is that differential equation that contains the nth order general differential equation. So now we are dealing with the second order differential equation, like y double dash means d2y by dx square plus p of x, y dash means dy by dx plus q of x into y equals to 0. So basically the second order linear differential equation, that is a2 into d2y by a2 of x into d2y by dx square plus a1 of x into dy by dx plus a naught of x into y equals to 0. So that is linear differential equation, and we convert it into this form by dividing the leading coefficient. Leading coefficient in that differential equation is a2 of x. So if we divide a2 of x in that second order differential equation, we get this standard form. And now this standard form is because a1 divided by a2x is also a coefficient function, and a naught x divided by a2x is also a coefficient function, so we call it as p of x and here q of x. So that is the standard form of this second order differential equation, and I am mentioning it as a. This is a homogeneous second order differential equation because right hand side is 0. If it is not homogeneous, then right hand side equals to g of x. Okay, its solution, because it is a second order differential equation, so its solution has the complementary solution basically. So that is called yc equals to c1 plus y1 of x plus c2 y2 of x. So basically it is a combination, linear combination of two functions, y1 of x into y2 of x. That is complementary function for homogeneous differential equation. If it is non-homogeneous differential equation, then we add the particular solution in that, and I will tell you how to find the complementary solutions and the particular solutions in the coming lectures. But now we are dealing with these type of solutions, c1 into y1x plus c2 into y2 of x. Okay, so this is second order differential equation, and today we are using reduction of order. By its name we can say that your order is by step your order is reduced in steps. Like if it is a second order, then we reduce its order into a first order, and then we reduce by using a suitable substitution, we reduce it into a specific function or a specific variable. So in this way your problem is solved. And basic purpose of using this reduction of order method is that if you have this type of differential equation and the solution is in this form, and one solution is given and the other solution is unknown, like y1 is given and y2 is unknown, then you can find out y2 by this reduction of order. And if y2 is given, then y1 is also determined by this method. I don't know people why find it difficult. This method is very complicated. They say that it's complicated, but I promise that this method is not that much complicated as people supposed to be. So only there are 4 to 5 steps, 4 to 5 assumptions, and your problem is solved. So very interesting method, and I like this method a lot. So basic purpose, I told you the purpose, that if one solution is given and other is unknown, then other solution is given by this, right? So we start the basic derivation or basic procedure of this method. And first of all, what you have to do, you have to assume. First assumption is do the heading method of solution. Okay, so first assumption is assume that y, basically y of x, is the combination of two functions u of x into y1 of x, and y is the given function or given solution of this. So you can also write it as u into y. That says that both these are dependent variables. In the next step, what you will do, you will take the derivative, first derivative. So basically for first derivative, because both of these are dependent variables, so if you differentiate this with x, then first derivative you have to use the product rule. First function derivative, second as it is, plus first function as it is and second function derivative. And in the next step we will take the second derivative. So second derivative is y double dash. Let me change the marker. So first function is, first function, if you take the derivative of first function, then you have to use the product rule. So derivative of first function is u double dash into y1 plus derivative of second function and first function as it is. Product rule in this second term, first function derivative, second as it is, plus first as it is and second function derivative. So this is the second derivative. The purpose of these taking derivatives, taking this derivative is you have to substitute in equation A. Now we substitute this all in equation A. Y double dash, here you have to substitute y double dash, here you have to substitute y dash, this value, and here you have to substitute u into y1. So first of all y double dash, second derivative is substituted as u double dash into y1 plus u1 dash into y1 dash plus u dash into y1 dash plus u into y1 double dash. So that is for second derivative, plus p of x and then y dash. Y dash is u dash into y1 plus u into y1 dash plus q of x into y, that is u into y1 equals to 0. Alright. Now in the next step what you have to do, sorry, it's not u1 here, it's u. Okay. In the next step what you have to do, you have to take, because in this assumption we already assume that y1 is a solution to equation A. This is our assumption basically. So y1 is given, you have to find y2. So I am taking y1 double dash term common and y1 dash common and q of x common. So I am taking this value, this value, this value and this value common. So what it becomes, I think u here is common, u here is common, u here is common. So I am writing u here, and it becomes y1 double dash plus p of x y1 plus q of x y1, and we write the rest of the terms. Rest of the terms are u double dash into y1 plus u dash into y1 dash. That is basically 2u, because these two terms are equal, so we can write it like this. Okay, and then this term is already written, and plus p of x u dash into y1, and this term is also written, this term and this term is also written, so that is equal to 0. Now we know that y1 is a solution of this equation. That means it satisfies the solution. It satisfies the solution, and if we substitute this y1 in terms of this, in this equation A, then y1 double dash plus p of x into y1 dash plus q of x into y1 dash, because it is a solution, so it satisfies the equation, that is equal to 0. So that means this equation is equal to 0. The purpose behind that combining this is this, right? Because being a solution, we reduce this equation, and now our equation is reduced to u double dash y1 plus 2u dash into y1 dash. Okay, now what is common here? I think u dash is common here, and here it is u double dash. So in the next step, we assume that w equals to u dash. So substitute in terms of w this equation, because I told you that order is reduced. So basic theme is your order. Let the assumption be your reduce your order. This is w dash, u double dash becomes w dash into y1 plus 2w into y1 dash, yes, plus p of x w into y1 equals to 0. Oh, right. W dash y1 plus, if I take w common, then 2 y1 dash plus p of x, I can write it as p. So you assume that it's a function of x into y1 equals to w. So definitely you can see that this equation is linear in w, right? dw by dx into y1 plus this term into w equals to 0. So this equation is linear in w. I'm writing it here, right? So now we are dealing with this equation. Further process for this is I'm writing it as dw by dx plus into y1 plus 2 y1 dash plus p into y1 into w equals to 0. So multiply this equation with dx. If we multiply this with equation with dx, then what it becomes, w into dx equals to 0. Alright, in the next step what we do, we divide by w. There is a purpose for doing these things, I will tell you in the end. Okay, divide this equation by w. When we divide it, it becomes 1 by w into dw into y1, and if we divide it with w, it gets cancelled and it becomes 2 y1 dash plus p into y1 into dx equals to 0. Okay, in the next step what we do, we divide this equation by y1. If we divide it with y1, this extra term, it becomes 1 by w. It simplifies basically. y1 divided by y1 is cancelled, plus 2 y1 dash. 2 y1 dash divided by y1 plus p into y1 divided by y1. So it becomes p into dx equals to 0. Okay, what's next? I can also write it as 1 by w dw plus 2 into 1 by y1 into y1 dash plus into like it's dx basically, plus p into dx equals to 0, and then integrating both sides. Integration gives, if we integrate these sides like this, and like this, so what will be the result? Tell me. It's a natural log of w. That is why I am combining these w, and that is why I am combining these y1. So I divided with w, I divided with y1 to combine these terms to get the integration possible. So natural log of w plus 2, that is y1, and into y1 dash 1 over function into function derivative. So that means natural log of y1. So power rule of function in integration, plus integral of p into dx, right, equals to c. C is the constant of the integration, and here we leave it as it is because it cannot be further integrated because we don't have a particular function in that. Okay, now we are using, let me arrange it, y1 dash square plus integral p dx equals to c. Okay, now I am using the property of log. Addition converts into multiplication product within that. So w into y1 dash square equals to minus p dx plus c. So to eliminate this natural log, what we do, we convert it into p into dx plus c. So e to the power c, if I split these two terms, then I can say that it's a e to the power c is also a constant, so I can say that it is a c1. So I can write it as c1 into e to the power integral p dx. Okay, now what I am going to do? I am going to do is w equals c1 divided by p into dx y1 dash square. So again, replacement of our assumption. Our assumption was this: w is equal to u dash. So I have to replace this w. It becomes, I'm writing here, u dash equals to c1 p dx divided by y1 dash square. This is the solution basically, but not exactly. One more thing is u dash is basically du by dx. So du by dx equals to c1 p dx divided by y1 square. And if we integrate both sides like this, cross multiply it and integrate it, then it becomes u. c1 is independent of these all the terms, integral e to the power minus p into dx divided by y1 square into dx. This dx is here, this dx plus c2, another constant. One more assumption is again replacement of u. From the very start we assume that this assumption that u is basically y is converted into u into y1. So u is what? U is, I'm writing here, u y equals to u into y1. So u is y divided by y1. So So I am replacing here the value of u, and that is y divided by y1 c1 into integral e to the power minus p into dx divided by y1 square dx plus c2. And if we multiply y1 on both sides, then we get c1 into y1 integral e to the power minus p to dx divided by y1 square. You don't have to cancel this because it is within the integral and it is outside the integral, so keep it as it is, into dx, don't confuse it, right? Plus c2 when it gets multiplied into y1. Alright, so combination of two constants and two functions. So first function, if it is given, the first function was given as y1. If the first function is given as y1 along with the constant 1, then this function along with the c1 is basically the another function. So here this other solution is determined by using the reduction of order. Now, number of steps. Conclude this all with our assumption. So first assumption is, let me do this. First assumption is this. Step number 1, right? Second assumption is this, w equals to u dash. This is step number 2, right? Third assumption, third is we divide it with w. Basically this is step number 3. We divide this statement with w. Step number 4, and then step number 5 is integration, and eventually it gets solved, and then a replacement of w into u dash, then replacement of u dash, replacement of u, and then this solution. So overall there are only 5 major steps to solve and use this reduction of order. So how you can see that how the order is reduced by second order to this first order, and then this first order to this simple step u into y1 dash.